class, in this video, we're going to be looking at an introduction to circular functions. The learning intention of this video is for us to know what a unit circle represents, to explore the features of a unit circle, to identify which quadrant an angle lies in, and lastly, to learn how to convert between degrees and radians. Throughout the entire lesson today, we're going to be mainly talking about angles. So we'll first start off talking about what is an angle. So as you are already aware, an angle is a measure of rotation, okay? It tells you how much you're rotating or how much you're turning. So for instance, if I'm keeping this arm over here constant, I can rotate and turn this arm around. And as you guys are already aware, there are many different types of angles. And if you keep turning it, then obviously you're going to have a greater magnitude, a greater size, okay? And often we label unknown angles or missing angles with Greek letters. For instance, we might use alpha, beta, or theta, but there are other Greek letters that could be used as well. Now, we've previously looked at what the unit circle is very briefly when we studied trigonometry. So for those who have already forgotten, a unit circle is a special type of circle where the radius is equal to 1. And because the radius is equal to 1, you could actually label these coordinates over here, these 4 coordinates, okay? So because the radius is 1, the distance from this point to this point is going to be 0, 1, because y is the 1 is the y value, so that's why the 1's over here. This is going to be 1 because that's along the x-axis, and this is going to be negative in these directions over here. The reason why the unit circle is so useful for maths is because we're able to calculate and find out the size of the sine, cosine, and tangent of any angle. We're not going to be looking at it at this particular lesson, but in future lessons, you'll see what I mean by this. In addition to that, angles are always measured anti-clockwise from this particular coordinate over here, okay? So the coordinate 1, 0 lies over here on the unit circle. So you're going to start from there. So that's where 0 degrees is measured from. And you're going to be moving anti-clockwise, okay? So anti-clockwise would therefore be moving in this particular direction over here. In addition to that, the unit circle is divided into 4 quadrants, into 4 sections, and you can kind of see that over here. That's one of them here, another one, and another one, so 4 sections in total. And again, we label this going in an anti-clockwise manner. So that's the reason why this is quadrant 1, then quadrant 2, then quadrant 3, then quadrant 4. And this over here shows you the degrees, the angle sizes within each particular quadrant, okay? And I'm hoping this is starting to ring a bell. Now, in terms of actually measuring angles, positive angles are always going to be measured in an anti-clockwise fashion. So we've stated earlier on. So for instance, if I was to move this red line over here up slightly a little bit, this over here is going to be read as positive 45 degrees, for instance. But if you go in the other direction, this is when it's so therefore in the clockwise direction, that should be not anti-clockwise, so that's clockwise. Negative angles are measured in the clockwise direction. So for instance, if you move downwards this time, therefore you're going to get a negative angle, as you can see over here by my example. Now, as you're already aware, angles are measured in degrees, but something that you may or may not know already is that angles could also be measured in radians as well. So radians is another commonly used unit to measure angles, okay? And you may have already encountered this or seen the word radian, because in your calculator, you would have noticed that there is a mode for degree mode, and there's another mode for radian mode as well. And that's denoted by the letter D and the letter R on top of the calculator. Now, in terms of distinguishing between these two types of measures over here, we know that something is in degree mode when you see this particular symbol over here. So that's the degree symbol. In contrast, when something is expressed in radian mode, instead, we don't actually have that symbol, so there is no unit whatsoever. But generally speaking, most angles that are measured in radians will generally have this symbol pi, okay? And if you are already familiar, pi is equal to 3.14, and the number keeps going on. So instead of just writing that number, we just shorten it and abbreviate by using this particular character over here instead, okay? And the key word over here that I want to emphasize is the word most. So about 80% of the time, or even higher, most of the questions that you are going to encounter that are expressed in radian mode will have pi in it. But in some other cases, it won't have pi. So an example of that could be 1.7. And you know that 1.7 will be expressed in radian as opposed to degree because it doesn't have the degree symbol, okay? So if it was just like this, that is expressed in radian, not degrees. It needs to have this symbol up here for it to be classified as in degrees mode. Now, you're probably wondering, what is the point of having two types of angle measures? And I don't really have a good answer to that, but similar to how other measurement systems work, there are generally more than one way for us to measure something. So for instance, let me give you an example. For distance, instead of measuring it with meters, you could use kilometers, yards, feet, etc. If you were to measure temperature, you have the option to use Celsius or Fahrenheit. And if you were trying to measure weight, for instance, you could use it grams, pounds. I think you get the idea, okay? So that's the reason why we have two different ways of measuring angles, okay? Because there will always be variations depending on where you live. But the best answer I could probably give you is that generally speaking, in the real life world, in the application setting, we often use degrees, like in architecture and geography, as this is something that's more easily understandable to most people, okay, without even that specialty in the field. However, in pure maths and in physics, so subjects that are a bit more, I suppose, hardcore in a sense, we generally use the unit radian instead, but we still use degrees in maths, but we're going to slowly transition and help you guys get more familiar and comfortable with the unit radians. Now, what I have over here on this particular slide is an image of the unit circle with some common angles that you are going to encounter for the remainder of this course as you study this subject, okay? So 30 degrees, 45, 60, etc., etc. You will see these angles quite frequently. But also, in addition to that, I'm going to show you the radian equivalent of each of these angles. And as you can see over here, you can readily identify that anything that is expressed in a radian form generally has a pi symbol. And most of them will generally be in the form of a fraction as well. For the entire unit, I do strongly encourage you to memorize some of the common radian equivalents of the certain angles. And the angles that I encourage you to memorize is 30 degrees, 45, 60, and the four, I suppose, corners or vertices of the unit circle. So 90, 180, 270, as well as 360 as well, okay? Now, something that you also need to be able to do is that you need to be able to identify, particularly when it's in the radian form, whether it lies in the first quadrant, the second quadrant, third quadrant, or fourth quadrant. And that can be particularly hard when it's in a radian form. When it's in degrees form, you can kind of tell immediately because you know that each quadrant is 90 degrees. So you can kind of work what that is. But when it's in radian form, it's going to be a bit more difficult, okay? And my strategy, my tip for you guys is that firstly, you need to memorize that 180 degrees is equal to pi and 360 degrees is equal to 2 pi. Now that you have this understanding, okay, we can kind of, I suppose, work it out very vaguely. Now, I've set up here, check to see if the given angle is less than or greater than a whole. In this case over here, think that a whole in this case is equal to pi, although we know that 360 is for a full circle. But for now, just think of a pi is equal to 1 whole. And if it's therefore less than 1 whole, then this would imply that the angle could either be in the first quadrant or the second quadrant. And if it's greater than a whole, then it's going to be either in the third quadrant or fourth quadrant. So what the hell do I mean by this? So let's just take these three examples over here. Notice that for these angles over here, notice that your denominator is always going to be greater than your numerator. And because the denominator is greater than your numerator, this implies that it's going to be found in the first and second quadrant. But as you can see in these examples over here, notice that your denominator is smaller than your numerator, and because it's smaller, that means it's greater than a whole, which is 100% in this case over here. So that's why it's going to be found in either the third or fourth quadrant. So that's a tip for you guys to help you guys memorize this. We're now going to be looking at an example for us to see which quadrant each angle lies in. So in our very first example, it reads 30 degrees, okay? So in this case over here, remember when you're trying to measure angles, all positive angles are measured anti-clockwise from this particular point. And because I know that each quadrant is 90 degrees, therefore 30 degrees should lie in quadrant 1, and if I was to draw it, then it would be something like this. So that's going to be quadrant 1. Similarly, 70 degrees is less than 90 degrees, and remember this is 90 degrees over here, so therefore this will also lie in quadrant 1 as well. Now for my next example, this is expressed in radian mode, and it's going to be a bit hard for us because I haven't shown you how to convert radians to degrees, and then for you to then use that to find out which quadrant it lies in. But I'm going to show you another way to do this, which is slightly inaccurate, but it still makes sense though, okay? So 2 pi on 3. Now, I want you to figure out, is that going to be found in quadrant 1, or is it quadrant 2, quadrant 3, or quadrant 4, based on whether it's going to be smaller than a whole or bigger than a whole. Now, notice in this case of it, because your denominator is bigger, then we definitely know it's going to lie in quadrant 1 or 2, okay, because it's less than a whole, so it's less than 180 degrees, okay. So therefore I can eliminate all options, quadrant 3 and quadrant 4. Now, in order for you to identify whether it lies in quadrant 1 or in quadrant 2, well, this over here is 0. You know that this over here is pi, and you know that this particular point over here is pi on 2, okay? These are some things that you just have to memorize. So you have to now see, does 2 pi on 3 lie closer to 0, which is more closer to quadrant 1, or does it lie more closely to quadrant 2? In this case over here, pi is the same thing as rewriting as 3 pi on 3. And notice that now that the denominator is the same, I can clearly see that, well, 2 pi on 3 is a lot more closer to 3 pi on 3 than it is closer to 0, right? So therefore, this is going to lie in quadrant 2. For the next example, 5 pi on 3, notice that your denominator is smaller, so therefore it's going to either lie in quadrant 3 or quadrant 4. For you to identify whether it lies in each of these quadrants, identify, does it lie closer to pi or 2 pi? To make things easier, make each of these numbers or have the exact same denominator. So I've converted this into 3 pi on 3. This is the same thing as writing 6 pi on 3. And therefore, just compare this number with each of the numbers here. So is 5 pi on 3 closer to 3 pi on 3 or closer to 6 pi on 3? It's closer to 6 pi on 3, so therefore it's going to be found in quadrant 4. Negative 110, because this is a negative angle, negative angles are measured in the clockwise direction, okay? So if you are moving in the clockwise direction, we know that this already is 90, and so therefore the extra 20 is therefore going to be somewhere around over here. So hence it's going to lie in quadrant 3. And for the last example, negative pi on 6. In this case over here, because this is a small fraction, you can kind of tell already this is 1 on 6. Then you know that it's going to lie in either this quadrant or this quadrant, moving in this direction because it's a negative. Because it's a small angle, therefore it's going to lie in quadrant 4. But notice that for each of these examples of here, the ones that are expressed in radian, it'd be a lot more easier if we knew how to convert this into degrees and then identify which quadrant it lies in. But for now, what I'm going to ask you to do is I want you to please have a go answering these 4 questions over here. Give yourself 5 minutes or so to answer these questions, and then we'll compare our answers together. So for our first question over here, 7 pi on 4, the answer for this one is going to lie in the 4th quadrant. How do I know it's going to lie in the 4th quadrant? Well, notice over here, this is greater than a whole, so it either will lie in the 3rd quadrant or the 4th quadrant. So therefore, in this case, to identify whether it's going to lie in the 3rd quadrant or 4th quadrant, what I do is I convert pi and 2 pi, in this case, to have the same denominator. So therefore, I could write that as 4 pi on 4 and 8 pi on 4. And once I do that, I then ask myself, okay, is 7 pi on 4 closer to 2 pi, which is 360, or is it more closer to pi? In this case over here, 7 pi on 4 is more close to 8 pi on 4, so that's closer to the 4th quadrant. So that's how I got my answer over here. 5 pi on 6, in this case, the denominator is bigger, so it's going to lie in the 1st quadrant or the 2nd quadrant. So I'm just going to ask myself, is it closer to 0 or is it closer to pi? So in this case over here, I'll do the same thing. I'm just going to make this have the exact same denominator. So 0 on 6, that's going to be 0. And this can be written as 6 pi on 6. So I ask myself, is 5 pi on 6 closer to 0 or is it closer to 6 pi and 6? In this case, I hope you agree that's closer to 6 pi and 6, so therefore this lies in the second quadrant. Negative 200 degrees, because it's negative, you're going to go in a clockwise manner, okay? So going in a clockwise, we know that this is 90, that's going to be 180, so therefore 200 is going to be around over here, going in this particular direction, so therefore that's going to be in quadrant 2. And for the last one, this is 80 degrees, positive angle, so you're going anti-clockwise, less than 90, so therefore it's going to be quadrant 1. We're now moving into the last part of today's lesson, and this is the main part, where you're going to be looking at converting between degrees and radians, okay? So in order for you to do this, you're going to pretty much use the formula that I have illustrated on this particular slide. So if you want to convert from degrees to radians, what you do with a number that's given to you is you multiply that by pi on 180. And if you wanted to go from radians back to degrees, then you're going to go multiply that by 180 by pi. So it's pretty much the reciprocal, okay, of each other. Now, although this simple step looks quite easy for you to do this conversion, it is actually really important that you know how to do this by hand. You can obviously do this quite easily with a calculator, but some of the questions that we do give you when we do come back to school, there will be a non-calculator component to it, so that's why you need to know how to do this without a calculator. So let's go through some examples over here. So in the first example, we're going to be converting from degrees to radians. Okay, so I've got 45 degrees and 150. You can easily see that these are the answers, but I'm going to show you how to arrive to the answers by doing things by hand. So what I'll do is I'm going to multiply this by pi on over 180, okay? So I'll do that, it's going to become 45 pi over 180. Once I get up to this stage over here, it's super important for us to actually simplify this. So find out what common factors go into 45 as well as 180. In this case over here, you'd agree that 9 goes into both 45 and 180. So you can cancel out these 9s over here. So you're going to be left with 5 pi on 20. And we know that 5 can also go into the numerator as well as the denominator. So therefore, if you simplify that, then that just becomes pi over 4. So as you can see over here, that is the answer. So we'll do another example. So 150 degrees, again, you're going to multiply that by pi over 180. If you do this, then you can easily see that the common factor between 150 and 180 is going to be 30. So you can therefore cancel out the 30. So therefore your answer is going to be 5 pi on 6. So these are quite easy examples over here. Let's now go in the other direction. So that should read radians to degrees, okay? So if you want to do the other way around, what you do is you multiply by 180 over pi. So if you do this, what actually happens is that the pi's actually cancel each other out. So once you've actually multiplied things horizontally, so 2 times 180 is 360, and 3 times pi is just 3 pi, you can therefore cancel out the pi's, okay? The pi's cancel each other out. And once you do that, then we can go 360 divided by 3. That's quick math. That's going to equal to 120. And you can clearly see that that is the answer over here as well. To go 3 pi into degrees, you again multiply that by 180 over pi. So therefore 3 times 180 is equal to 540. And 2 times pi is 2 pi. And therefore the pi's cancel each other out. What is half of 540? That's equal to 270. And we can clearly see that's the answer as well. I want you to now have a go of answering these questions. So give yourself 5 minutes and then we'll compare our answers together. So for the very first question over here, you're converting from radians to degrees. So if you're converting from radians to degrees, then you're going to be multiplying by 180 over pi. So therefore, if you multiply that by 180 over pi, then this is what you'd get. The pi's would cancel each other out. So what is 720 divided by 3? That equals to 210 in this case over here. Do the same thing for the second question. And you cancel out the pi's. What is 1,206 divided by 4? That's equal to 315. For question 3, you're multiplying by pi on 180. And then you're going to need to simplify. So what factor is going to 135 and 180? In this case over here, I'm going to say 5 goes into both the numerator and the denominator. So you can cancel out the 5s like this. What can go into 27 and 36? In this case, 9 is the highest factor. So divide the numerator and denominator by 9. Hence, you're going to get 3 pi over 4. And for the very last question, 300 degrees, multiply that by pi on 180. find out what factors are going to 300 as well as 180. That's going to be 30 in this case over here. So therefore the 30s will cancel each other out. Find out what can go into 10 and 6. That's going to be 2. So therefore divide everything by 2. Hence you're going to get 5 pi on 3. So that's the very last example over here. What I'd like you to do now is I want you to have a go answering these questions. And once you've finished answering those questions, then that's about it for today's lesson. Hopefully you're able to meet the success criteria of today's lesson. Thank you for watching today's video. I'll see you guys again in the next video. Bye.